All right, now we're back and we're talking about the Windows API. Now, API stands for Application Programming Interface. Now, I want you to think of the Windows API like this. Way back in the day, when the very, very smart people who designed the Windows operating system were working on it, they said, hey, we work on the operating system all the way down here, which is a very low kind of code to be working on. Now, down at the heart of the operating system, you're really dealing with things like zeros, ones, and instructions like jump and XOR and lots of very, very low things like that, right? Now, as the operating system developed, certain features of the operating system were developed as well. And so the programmers decided, hey, instead of requiring people to be working all the way down here at the very, very gritty low operating system level, why don't we expose these functions of the operating system so that anybody who wants to design a program and write a program in something like C or C++ can make use of these functions instead of tapping into the very, very low code of the operating system. And so what you can think of these functions is easier to work with versions of these very, very low-level programs that are running inside of the operating system. So the Windows API can do things like, hey, if you want to download from URL, you can use this API, and in your C or C++ program, instead of writing a whole bunch of low-level code, you can just say download from URL. And then you would define that in your program. And so as part of the Windows operating system, we now have this application programming interface called download URL. And so if we want to use that in our program, we need to supply it a few things. We need to say which URL to go to and which file to download. And where do we want our out file? And what will that file be called? And so Microsoft put together documentation that says, hey, if you want to use this program inside of your own program, you just need to supply a very specific defined pattern of information. And thus, the Windows API was born. Now, programmers all over the world can make use of all of these functions. All they have to do is import them from the operating system. Now, is the Windows API bad? No, it is not. Many different programmers from many different walks of life are able to use the Windows API for all kinds of programs. But that means that malware authors can use it too. Now, if we look at the import address table, we start to get a feel for what kind of API calls this portable executable is making. And so right off the bat, to the untrained eye, none of this might look really that interesting, but there are a few things that jump out to me. So when you see something like shell execute W, if you don't know what that is, maybe all you need to do is open up the documentation for it. So we go right over here to old Google's, and we're going to say the Windows API shell execute. Now, Microsoft has documentation for each of these functions. So shell execute A performs an operation on a specified file. So this is an example of one of the API calls that a program can make. You can tap right into the operating system and call this, and it has like a built-in function to allow you to do some kind of thing. So that is definitely something of interest. Again, we don't have enough to say that this is definitively evil at this point, but it is a very big indicator. And if we keep looking, we're going to see other things that might be indicators as well. How about this one? URL downloads a file. That was kind of the example that I was giving when I was explaining the Windows 32 API. Well, here is the actual API call. Again, if you don't know what this is, go over to the Googles, and we're going to do URL download to file. Downloads bits from the internet and saves them to a file. Now, that can be pretty telling, But a lot of different programs might use that kind of API call. Maybe Spotify uses that to download playlists. Maybe your bank application uses that to sync your information to your accounts. But if we already know and anticipate that this file has malicious functions, this is a pretty big indicator that this malware might be trying to download some kind of second stage executable. So again, you can look at the different parameters here of how this function is invoked or called. And all it really requires is a URL to actually download from, the file name, and it will write that file to the file system somewhere. So this is the import address table. This can be very telling about what a piece of malware is doing at any given point. But we don't know if these programs are even invoked yet because we have not run the binary. And that wraps up looking at PE view to identify a few of the characteristics of the import address table, the compile time, and some of the different section headers. And so we are going to move on with our static analysis.